Hello, yes, I hope you're doing well. Yeah, welcome back to the O-level physics revision series. I'm teacher Dennis Monday. So here we're looking at resultant forces, or what you mean by a resultant force. What is a resultant force? So what you mean by a resultant force is just one force, a single force which has the same effect as a number of forces acting on a body. So we are going to look at different cases that we can consider when calculating the resultant force. So the cases are different. Let's look at case 1, when the forces are acting in the same direction. So remember, force is simply a push or a pull, upon an object. So you have F1 acting in that direction and F2 also in that direction. They are all acting in the same direction. The resultant force F is simply going to be F1 plus F2. There are cases when they will not put them on opposite sides. What matters is the direction. So you may find a case where they put F1 around there, F1 there, F2 there. The resultant force F is simply the sum of the two. An example is if you have a body being acted upon by 2 newtons and 3 newtons. What is the resultant force here? The resultant force here, which you call F, is simply going to be the sum of the two. You get 2 plus 3 newtons, and that gives us 5 newtons. So that should be very easy for you to see. Now, let's look at case number 2. If the forces are acting in opposite directions for case 2, what do we do? So, we have a force here, a force F2, okay, and then F1, like that. So, what is the resultant force? Now, here we have two approaches. You can easily get the resultant force as the bigger one minus the smaller one, but conventionally, we usually take the forces acting to the right as positive ones and those acting to the left as the negative. So, since this is ordinary level, I will take the idea of the first case, where we look at the larger force minus the smaller force. Larger force, here we just subtract the resultant force F is going to be F2 minus F1. That is if F2 is greater than F1. So you get this, the bigger one minus the smaller one. Now if the bigger one is this way, this side, that means you're going to end up with a negative answer, which will be telling you that the body will be moving in that direction, negative x-axis, in this direction. Though, like I told you, we are using the first case, the first way of explaining. We can always just take the bigger one minus the smaller one. That's all. An example is if I have a body here of mass 2 kilograms being acted upon by a force of 20 newtons and another force of 10 newtons. And then I am told to calculate the resultant force and hence the acceleration, and hence the acceleration of the body. So what do you do? 20 newtons, 10 newtons. So when you're answering such a question, let me just use this space just right here. You get the bigger one minus the smaller one. So the resultant force F is going to be the bigger one, which is 20, minus the smaller one, which is 10. So we end up with the resultant force of 10 newtons. Very good. Now, how do we get the acceleration of the body? You remember that from Newton's second law of motion, we had the F is equal to ma. F is equal to ma. F is the resultant force, which is 10, should be equal to mass. The mass is given as 2 kilograms. The mass should be in kilograms. If it's given in grams, you convert to kilograms by dividing by 1000 times A. So, dividing through, our acceleration is going to be 10 over 5 over 2, is 5 meters per second squared. You can even choose to write 5 newtons per kilogram. It is also correct. If you have a case where the bigger force is acting to the left, so you have case, this is our body, and there is a force of 8 newtons, and here we have a force of 3 newtons. This is a 1.5 kilogram mass. So what is the resultant force? The resultant force F is going to be, you get the bigger one minus the smaller one. So which gives us 5 newtons. But remember, in the direction of the 8 newtons force, so for this case the resultant force will be acting in this direction. 5 newtons in the direction of the 8 newtons force. But if you are to follow the conventional way, where the ones that act to the right are positives and those acting to the left are negatives, then you will have this written as 3 newtons minus 8 newtons, giving us a minus 5 newtons. Where this negative is just showing us that it is acting in this direction. So for O level, either way, you are correct, though this is the most correct one. Negative 5 just tells us that it is acting to the left. Okay, then the acceleration, of course, if you're looking at the acceleration, you just use the magnitude of this force, and then the mass is here. So the acceleration is given by resultant force over the mass. The resultant force is 5 divided by 1.5. Yeah, you can go on and compute and then get an answer in meters per second squared. The last scenario, the last case is if the forces are acting perpendicular. The forces are acting perpendicular. So case 3, where the forces are acting perpendicular to each other, perpendicular forces. So you may have different scenarios, like look at this case. I have a force of 3 newtons acting on that body, and then here we have 4 newtons. Okay, so what is the resultant force? Now someone may decide to say, if you say that the resultant force here, F equals to 3 plus 4, that is wrong, because they are not acting in the same direction. Now someone will say they are acting in different directions. So let me subtract. Resultant force F equals to 4 minus 3. That is also wrong. So what do we do? Now here we are going to bring in the idea of Pythagoras theorem. Look at this 3 newtons force. It is acting vertically. So it's acting vertically. 3 newtons. So we are getting the resultant. So it's like you get this and then you add. Remember, forces are vectors. Vectors, a vector quantity is a physical quantity which has both magnitude and direction. So you want to get the resultant of the two. So you have this one combining with this one. So where this arrow ends, we are combining. This one is horizontal, so we transplant and put it up. So we have the 4 newtons force. Instead of putting it here, I did this arrow and this arrow. So the resultant is that. The resultant force is that one. So do you realize that if this side, if I'm now to represent in terms of sides, if this is 3 and this side is 4, you see that this is the hypotenuse. The hypotenuse. So this is the horizontal force, we call it Fx. The vertical force, we call it Fy. So what does Pythagoras' theorem say? It tells us that if you want to get the hypotenuse, which is f squared, you get the base, which is fx squared, plus the height, which is fy squared. Just because here we are reasoning in terms of forces. So in summary, if forces are perpendicular, the resultant force is given by please don't forget this. I'm going to look at a few examples and we close. So examples. The first case is first example is you have a body here that is being acted upon by a force of 12 newtons, and here we have 5 newtons. This should be longer than this, but just because of the space. But we have to know that if this is our body, let me assume a point of action, or the center of gravity is here. Just assuming. So the resultant force will always act between the two. The resultant force will always act between the two. So for our case here, 3 newtons, 4 newtons, our F is going to be here. Actually, if I'm to use this as the first example, the resultant force is, we said Fx squared plus Fy squared, whole thing under root. What is Fx? The horizontal one is 4. 4 squared plus, what is the vertical one? 3. 3 squared under root, which is 16 plus 9 under square root, which is 25 under root. Gives us two values. One is a positive, one is a negative. We are interested in the positive one. So the resultant force is 5 newtons. For this case here, we do the same story. The same thing. The horizontal force, you can see clearly, is 12. The vertical force, Fy, is 5. It's 5 newtons. So implying that the resultant force is going to be Fx squared plus Fy squared, the whole thing under root. And what does that become? So this is 12 squared plus 5 squared under root. 144 plus 25 under square root, which gives us 169 under root. Two values, positive and negative, of 13. We take 13 newtons. So the resultant force is 13 newtons. So those are the basic cases. The last case which I want to explore is, so you have a body. Don't worry, I'm not putting the questions in full, and just putting a few. Maybe it's a doll, a few words. So here you have a 20 newtons force. Then this side you have a 15 newtons force. 15 newtons. Then you have a force. You have a force of 18 newtons. And you have another force. Here there are many. 18 newtons. Then up this way we have a force of 6 newtons. So how do you get the resultant force acting on the body? Remember we said once you realize that they're acting perpendicular, so you're going to use that formula, that the resultant force is going to be Fx squared plus Fy squared, the whole thing under root. But what is Fx? What is the resultant in the horizontal, in the x direction? What's the resultant force in the x direction? In the x direction, the resultant shall get bigger one minus smaller one. Bigger one minus smaller one. So it's going to be 20 minus 15, giving us 5 newtons. And what about vertically? Fy, bigger one is downwards, 18, minus the smaller one, which is 6, giving us 12 newtons. So you see? So now we have that our Fx is 5, our Fy is 12. Don't pick them direct. Get the resultant in the horizontal, the resultant in the vertical. So therefore, this implies that F equals 2. Where there is Fx, we put 5 squared plus 12 squared, the whole thing under root. What does this give us? 25 plus 144 under root, which is equal to 169 under root, and that is 13 newtons. Like that, you can easily solve any question that will ask you to get the resultant force if you know those approaches. Sometimes, maybe for the last example, example 3. This is also easy. Actually, this can be as your exercise. Get the resultant force that is acting on this type of body. Thank you. Let's meet in the next lesson. Bye.